Hi Mickey, Ian here. So these are the steps that I'm going to show you for being able to vectorize and digitize the geological information from those maps you sent me. So I'm going to start with the Ngozi geological map. So if we look at it here, this is the map we want. So now I haven't been able to locate any information with regards to the ellipsoid or spheroid that's been used. But if we assume that it's WGS84, which I think is a safe assumption based on the date of the image, we'll see how we can georeference this. So what we've got is we need some control points to georeference this, and we've got the control points in the top left hand and right hand corner of the map, and they're also sort of repeated in this grid here. So now that is the section for Ngozi that we're going to capture. But ultimately, you're also going to capture the rest of these. So I thought, let's just go ahead and vectorize, or actually create a grid for the entire area, so that we can then, once we've done this one, you can use that same grid to georeference the other images. So that's what we'll do. We'll use this grid to actually georeference the images. Okay, so what I want to do is just capture this in a little spreadsheet. So I'm going to open up Excel and a new sheet. I'm just going to minimize that slightly and move this off to the side. Let's actually move this one to the side there and put this one over here. Okay, so what we're going to do is create a spreadsheet with the coordinates for each of those points. So we're just going to call the first one point. We'll go lat for latitude and longitude, longitude. Okay, and we'll start with the latitude. Okay, so running down the left-hand margin here, we've got all the latitudes. So that is 2 degrees. So we just type in 2 degrees. This is 2 degrees and 30 minutes, which is the same as 2.5 decimal degrees. And the next one is 3. The next one is 3.5, and then 4 and 4.5. Okay, so there's the latitude running down the left-hand margin. So now what we'll also do is we're going to capture the longitudinal lines, which is 29, 29.5, 30, 30.5, and 31. So those are the longitudinal lines. So for the first set of points, which will just be the ones running down the longitudinal line for 29, we can just type in 29. And 29. Okay, so now when we bring that in a CSV, we should have dots for each of those points. So we're going to repeat that step for the next longitudinal line, or for the next 4 longitudinal lines. So we're going to copy the latitudes, and we're going to repaste those, and then we're going to go 29.5, 29.5, copy that, and we're going to paste it there. And then 30. Just make this a bit bigger so I can see what's going on. Make that 30. And there's actually another one. It's 30.5 as well. So I need to have some more points for the latitude for our last longitudinal line, which is 31 degrees east. Okay, there we go. So now we have the longitude and latitude for each of the points of this grid, and then what we can do is we can just have the actual, we'll just give it a random, not a random, we'll just give it a letter of the alphabet for each of the points. So we're just going to go A, B, C, D, J, Q, R, S, T, U, V, W, X, Y, Z, and we'll go A, B, A, C, A, D. Okay, so I mean, this is not really important. This is what's important here. But the other thing we need to change is the latitude is currently positive. We need that to be a negative number because it's actually south of the equator. So that needs to be negative. So we can just say equals that times -1. And we'll just copy these, paste them all down there. I'm just going to copy this entire column, and then I'm just going to replace everything that was there. I can delete that. Now we've got the negative values, right? So what I'll do is I'll save this as an Excel spreadsheet in case there's any errors, and then I'll export and save it as a CSV. So we're going to put it on our desktop. I had a new folder which I called, what did I call it? Geological map sheets. And I'll stick it in here. I'll just call it coords. Okay, so that's it saved as an Excel spreadsheet. Now I want to save that as a CSV. So I'm going to say save as. I'll stick it in the same place. And it's comma delimited, CSV, coords.csv, save. Okay, so that should work. Let's just save it once more, just in case it didn't save through. Okay, right. So now we should have all the points which we'll bring in to create this grid. And then once we've done that, we will use the Ngozi portion of that grid to georeference this image. So let's open up QGIS. Open up a session of QGIS. Okay, there we go. So we've got a blank project, and we are going to bring in those CSV points. So first of all, I can see here that my default projection is EPSG 4326, which is WGS84, which is the projection I am going to assume, or the coordinate reference system I'm going to assume for that grid from the geological map. So let's add that CSV. I'll just go find it on our system. So it is, first of all, we need to choose the delimited text option, and then we'll go find it. It's on my desktop in Geological Map Sheets, Data Spatial Table. There it is there. Okay, and it looks like it's defaulting to my previously selected coordinate reference system, so I just need to make sure I choose the EPSG 4326. And everything else looks fine. It looks like it's coming in. We've got our 3 separate columns here, so I think that's good. So let's say add and close. And that looks pretty much like the grid that we had on that raster or that image. So I am happy with that. What I can do, just to double check that it's in the right place, is I'll use the quick map services. I'll just use any one of these. Maybe I could use the Google Street Map layer, which is this one, Google Roads. And we'll see if it's in the right place. Okay, so it is basically in the right place. It's over Burundi, so I'm happy that is in the right place. So let's remove the, actually, you know what, we'll just turn it off. Okay, so now the idea is that we are going to be digitizing the geological features as polygons for each of these tiles. So first what we need to do is we are going to need to georeference those tiles, and then we will actually capture the polygons. So before I do that, I'm going to create a grid, a polygon grid with a square or a tile for each one of these tiles, and then I will use that polygon in digitizing the geological features at a later stage. So let's just start with that. So what I want to do is I want to create a new polygon. So I'm going to say create a new layer, and if the shape file is fine, it is going to be a polygon, and we're going to put it in that same folder. I've got a folder called vector, and we'll just call this map tiles. Oof, I need to change my caps lock. Map tiles, save. Okay, we'll use the same coordinate reference system, and we can just say name. We can always add more fields later if this isn't sufficient, but for now I think this is fine. So let's say OK. And now what we're going to do is we are going to use these points to create those tiles. So what I'll do is I want to be able to snap to these tiles to get a nice accurate georeference, a nice accurate capture for these tiles. So I'm going to go to my project settings, go to snapping options, and it's on my second screen here. I just want to make sure that the snapping options are active, and I'm going to snap to chords. Okay, that looks good. Alright, so let's start with that. And I need to capture a new feature. So I'm going to toggle editing. Okay, I'm going to capture a new feature. What I want to do is I want to capture a new vertex for every single point that's here, because these won't necessarily be in a straight line. So I just want to make sure that each line segment is captured for my new polygon. So and then the other thing that I'll do is I'll capture the entire area, and then I will use the advanced digitizing tools here. There's the splitting features to actually then chop it in half. So I won't be capturing each separate tile, although there's nothing wrong with that. This might just be a quicker way to do it. So let me just go ahead and show you what I want to do there. So I'm capturing each little line segment for the border. And see with the snapping tool, it's quite nice. The minute you get close to one of the points, a little pink square pops up to let you know that you've snapped onto that point. You want to right click to finish. And for name and ID, I'm just going to leave those blank. I can always update those later. Okay, so what I'll do is I'm just going to change the size and color of this, because I'm not sure whether it's going to be nicely visible on the video that I'm creating here. So I'll make it a different color. Okay, there we go. So now we can see each one of those points. Okay, so like I said, now I want to chop that up. So I'm going to use the advanced digitizing tools. So I'm going to select the polygon I want to chop up, and then I'm going to choose split features, and I want to intersect all these lines. So I'm going to start digitizing outside, click on the border, and then capture the line segments between each of these points, and then right click to finish. There we go, it's chopped that up perfectly. And then I'll do the same thing again with the next one. This time I'm going to start at the bottom, because I think when I finished digitizing, it's it was selecting, or it was leaving the bottom polygon the selected feature, and this just saves me a step. Okay, so now what we'll do is we're going to split it this way. And I'll do the same thing as I did last time. I'll start on the right hand side, because it looks like it is deselecting the wrong ones for my purposes here. And last one. Okay, there we go. So I can save those edits, and I can deselect everything. And that should now be a accurate grid of the raster image. So let's have a quick look at this one again. So if we look at it, it's 2 rows down and 2 across. That is the polygon that we're going to be capturing, and it's called Ngozi. So we've captured the polygon. We're going to use that one to now georeference the image. So it's this one here. So let's just go and call that Ngozi. I'll start editing again. And the other thing I can do is just give each of these a unique ID. So I'm going to deselect everything. I'm going to use my little field calculator. I'm going to update the ID field, and I just want the unique numbers. So I'm just going to go at row number. Okay, and that'll just number these 1 to 20. Or it should do. Let's see. There we go. Numbers 1 to 20. Okay, so that's got a unique ID. And we've named our first one. Okay, so there's our grid. So what we will do then is use the georeferencer to georeference Ngozi. Okay, so let's do that. Let's activate the georeferencer. And if you didn't see your georeferencer there, you might need to go to the Manage and Install Plugins, and then go and select georeferencer from your plugins menu. And I think it's a core plugin, so it should be listed here with the installed plugins. And if it's not viewable from your raster menu, you might just need to turn it on. So go and turn that on, and once it's turned on, you'll have the georeferencer option available. Okay, so when you open up that, you should see your georeferencer window, And what we want to do is just add the raster that we want to georeference. So I'm going to say open raster, and we'll go to that same folder, and it is Geological. Now this one I saved in a folder called raster. There it is there. Okay, so it can see that it doesn't have a defined coordinate reference system. So that little message was just telling me that the program is assigning it a default coordinate reference system, which is fine. That's fine for now. Okay, so what we want to do is we are capturing this little layer here. So what I'm going to do is I'm just going to make sure that it renders and the others don't, so I don't get confused with the neighbors. So I'm going to say name equals to Ngozi. Okay, and then I'm going to zoom to the layer. Okay, so those are the ones we are going to use, or these are the ground control points that we are going to use for the georeferencing of this image. Okay, so first thing we need to do is zoom into the area or the point on the raster image that we want to georeference. Now this is where the two lines meet. So we're going to add a point as close to the center of where you imagine these 2 points meet. So maybe it's there. And then we tell the program to select the next point, or the true ground control point, from the map canvas. And then since we've still got our snap settings set, we'll just snap onto that coordinate point. And that's our first one. So let's go to the next one, which is up here in the top right hand corner. Zoom in nice and tightly so you can get an accurate georeferencing. Something like that. From map canvas, click on your point, OK, zoom to the full extent. We'll go bottom right next. We'll use that same add point. I haven't zoomed in close enough this time, but you can zoom in closer. The closer you zoom in, the potentially more accurate your georeferencing will be. That's for adding it to the raster. Since we're snapping to the points, that is always going to be accurate. So this first point is probably more important, to try and get this as close as possible to where you think the longitude and latitudinal lines meet. From map canvas, there we go. Okay. So now we've got our 4 ground control points added, and you can see they're reflected here by little red dots, and you've got a little ground control point table listed as well. Okay, so now we can go ahead and georeference that. So we just first want to change the transformation settings for the georeferencer, and you've got a number of options here. Now the easiest option is to choose linear and to just go ahead and create a world file. And what that'll then do is just create a little text file with the values for the georeferencing of that image. It'll have cell size as well as the top left hand corner coordinate for that cell. Now that'll work, but I think there's a rotational value which is going to come into it here as well. So I'm going to choose the second option, which will allow us to, it's going to re-render a completely new raster, and it's going to apply a little rotational value. So we're going to say, we're going to choose that one. We choose the same coordinate reference system or spatial reference system as it's listed here. And what this is going to do is going to create a whole new raster. So it's going to re-render a new raster, and this is what it's going to be called, modified.tif. That's fine. I'm not worried about that name. You can always change this name later, or you can change it now if you prefer a different name. Yeah, why don't we just go Ngozi SE? So we'll just make it a bit shorter. Yeah, okay, that's maybe a bit neater. Alright, it's going to stick it on our desktop on the C drive. So we can say OK, and it's going to load it in QGIS when done. So that's fine. So let's say OK. Alright, so nothing's happened yet, but our settings are set for the transformation. All we need to do now is hit this little play button to start georeferencing. So let's hit that play button and see what happens. Okay, that looks like it could be in the right place. I'm just going to stick my map tile on top and change the boundary to no brush. Maybe make the 0.5 and a different color. Maybe choose like a bluey so I can sort of see it. And then we can zoom in and see how accurate our georeferencing was, or inaccurate. Okay, you see it's not quite there. It's not 100% in the right place. Now I wonder, if we're having a look at the bottom right hand corner here, what is it out by? It's out by 236 meters, which is not great. Okay, so that's out by 236 meters, and this is out this way by 236 meters. Okay, so it has georeferenced it, but it looks like we might need to choose a different transformation setting to put it in the right place. So let's try that again, and this time we'll just choose a different transformation setting. We'll choose the polynomial 1 and just give that a name P1 for polynomial 1. We'll say OK. And let's run that again and see if it's any better this time. I'm just going to zoom to the full extent. I want to zoom to the extent of that layer again. And then we'll just click. Okay, so what has happened this time? That seems better. It's a lot closer. Okay, well, maybe we should look at the other points as well. Okay, not 100%, but at least it's not out by 250 meters. Now it's only out by 26 meters. Okay, so the accuracy, the importance of the accuracy will depend on what you need to use this data for. But this kind of works. You know, I think we can be happy with an inaccuracy of about 30 meters. You might find in the field that the accuracy changes slightly, but that's also going to depend on the scale that this geological map was captured at in any event. Okay, so let's assume we're happy with that. If you're not happy with that accuracy, you can maybe try the georeferencing again, or choose a different transformation setting and then see how that works out. But let's assume we're happy with this. Okay, so what I'm going to do is just remove the other modified or georeferenced image. So I'm going to remove that. Okay, so now we can go ahead and start digitizing the actual geological features. And we've got our legend running down here on the right hand side with the different formations. And this is all in French, so I guess the French speakers will be able to interpret this and decide whether something is sedimentary, basalt, igneous, granite, whatever. I wouldn't know what these are. But anyway, so what we're going to do is let's start by capturing a new shape. And I want to choose an easy one because it's going to be a bit easier for me to show you how to do that than to capture something that's more difficult. Okay, so what I'll do is I'm going to capture this shape here, and it is like that brownie one, which is it's got a name of, which one was it? GIMC, whatever, well, GIMK, whatever that is. GIMK. Okay, so what you can do is you can create a new polygon. Let's turn the georeferencer off for now, we don't need that anymore. Okay, so what you can do is you can create a new polygon and then start capturing each of the separate features. Of course, the problem with that is going to be that when you get to two features next to each other, for instance, let's say this light pink area and then this yellow area, you're going to need to digitize that polygon and then this polygon, and then the shared boundary will be digitized twice. Okay, so it's going to take you twice as long, but the other thing is the shared boundary is not going to be the same because you're going to be digitizing it twice, and that'll depend on the scale that you digitized it at. So a better way to do that, or to do any of this, I would say, is to take the original map tile that we've created. Okay, let's go and select this, and it's called Ngozi, so I'm going to go export, save selected features, and let's just call it Ngozi Geo. Alright, we'll say OK, and there you go. So now this is a polygon on its own. The map tile, the original grid, is left unchanged. We are going to do some edits, but we're only going to make the edits to this Ngozi Geo. So what I'll do is I'm just going to change the color slightly so I can see what's happening underneath, and I'll make it like a sort of an apple green, and then change the layer transparency down to, like, let's try 30% for now, so we can see what's going on behind. Okay, and now this is where you're going to start using your advanced digitizing tools. So you may need to turn these on, and to do that you just right click and then come and select the advanced digitizing toolbar under toolbars. You can also go to view, toolbars, and then choose advanced digitizing toolbar. So let's capture this first one here. Okay, so what we need to do is we need to make sure that the layer we want to digitize is selected, or the active layer, and then we click on the pen to start digitizing. And now what we're going to do is capture this feature, and we are going to capture this feature using the ring tool. So we're going to add a ring, but we don't want the ring to disappear, so we're going to add, I think it's this option here, this one, add fill ring. Okay, so select add fill ring, and then possibly decide on a scale you want to capture at. Maybe I need to zoom in a bit more, but then the accuracy of your technicians is going to depend on the sort of scale that they're at. So maybe choose a scale that you feel comfortable that everyone's going to be digitizing at, and then tell everyone, look, you're only allowed to capture at 20,000 or 35 and no less. So then everyone's got a uniform sort of scale that they're digitizing at. Okay, so let's go see that add fill ring, and let's capture this piece. And this is why I think it's going to be time consuming. I mean, there are so many different geological features that this could take a while. That's why I chose this easy shape. I didn't want to be stuck digitizing this for too long. And in fact, I'm going to be a little lazy. I'm not going to capture it 100%. And then right click to finish. And I see we need a new field. So this is where we can type in formation, let's say. So for now I'm just going to say OK. I'm going to open up my attribute table. I'm going to capture create a new field, call it formation, and it'll be text, and they were pretty abbreviated characters, so I'll just give it a length of 25. It's probably a bit too long for it. And then just close that down, select that feature, and then open my attribute table again. And this one was, I wrote it down here, it's GI, and then it was hyphenated MK. Maybe put a space and a space. Okay, so something like that. Okay, so there's our first feature. So now, if I zoom to the full extent of that tile, which is the Ngozi features, we've captured our first feature using the add ring tool. So now the other thing you can do, instead of just using the add ring tool, is we can come in here, and since there's no shape here and a shape here, we can come in from the boundary and cut that piece out using this tool here, which is the split features tool. So I'm going to intersect the edge. So I'm going to start digitizing outside of my boundary and then capture the feature. And I'll be even lazier this time. I won't capture this too accurately, just to give you an idea of how to go ahead and do this. Be sure I don't double click or do anything wrong. If you end up going sort of like off whack a bit, you can just hit delete on your keyboard to delete the previously added vertex, which is easy enough. And then once you intersect the boundary again, you need to digitize a point outside and then right click, and then what it does is it chops out that piece. Okay, so now what we can do is let's just turn this off to see what the color was. It's a yellowy color. So what I'm going to do is select that feature, zoom to the image extent, go and have a look at what the formation code was there, RU. Open up my attribute table again, and then type in there RU, and zoom to the extent again. Okay, so now I've got two features. One was added using a little an island, or what do they call it? It was this one here, fill ring, and then the other one was chop a piece off of it. So you see how by using a giant polygon for the entire area and then cutting it up, I was able to avoid digitizing this boundary twice. So now if I just want to capture that piece there, then all I need to do is I need to split this feature along that line. So let's see how I would do that. So I need to start. Now what you can do is you can maybe change your settings at some point. So we go to our snap settings. Now we're going to start snapping onto the actual vertex and lines of our layer that we're digitizing. Just capture this boundary line here, and then intersect with our tile border again. Right click to finish editing, and now we've got this piece. And what color was that? It's like a light pink. Out of these pinks, ooh, could be that one, which is KI. So yeah, if you need anyone to verify this, you'll just need to give them a shout and see. But you can always come back and change the values for each of these features later. The main point, the most important point up front is to capture them correctly. Okay, so there we go. And as you start adding them, what you could do is you could go to properties, and then we're going to say categorized, and we categorize based on formation. We'll classify. You're always going to have a blank one. Now the blank one will be for every feature that hasn't got a value added yet. So we'll make that the bottle green color, let's say. And then the other ones were, this one was like a browny color. Not that brown, something like that. And this one was yellow. Yellow is never a great color because it often gets confused with the selection color. So maybe we can, we'll just use yellow for now. And then KI, which was that light pink color, something like that. All right. So now if we apply that, so now we can turn off, and we can start seeing corresponding sort of colors to the actual formations that we're capturing. And then the fact that we've got a blank color that is green will allow every feature that hasn't been captured yet to still be rendered. And yeah, maybe I can just show you why I thought this might be a bit of an exercise, is because you've got all these little fingers and these geological formations that run inside others. So for instance, you might need to figure out how best to start capturing these features. Do you leave these ones till last, and then capture this orange feature, and then capture these islands? It is quite an exercise, but what you should do is, if you get stuck with maybe how to sort of go about and the steps in capturing this feature and adding these features later, just give me a shout. But then lastly, what I just wanted to mention is we've just captured the geological features for Ngozi. If you want to capture the neighboring tile as well, you'll just need to go and georeference that tile as you have here. And then what you can do is, once this is, let's say this is all finished up, what you can do is, provided you have the same values for the formations, what you can then do is do a dissolve. And when you dissolve neighboring features, as long as the features next to each other are the same and they share an identical boundary, then this little section will be bled in, and then this formation will run through. So maybe that's the last thing to do. Start off by having a geological map for each of the separate tiles, and as a final step, do a dissolve on the geological features. And that is how you would do that. So yeah, give us a shout if you have any questions with regards to how to capture those geological features. And based on that little exercise, if we look at the full list of grids, well, where are we here? I just need to pan up slightly. If we zoom in slightly here, you can see there's 1, 2, 3, 4, 5, 6, 7. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, like 17 of those. So maybe it's not going to take that long. You know, it doesn't look like it's a 3-month project just to go and digitize this. If you have one person's allocated time just to go through it, maybe it shouldn't take them more than a month. I'm guessing. I guess it does depend on their skill level, but that's kind of my idea. Maybe this whole exercise in digitizing the geological features isn't going to take as long as we initially thought. Okay, yeah. So good luck with that. Give me a shout if you have any questions. Yeah, I'm always here for you guys. So give me a shout. Chat to you soon. Cheers.